And a PlayStation. Nice. Cool. Awesome. Okay, cool. So just one other thing I forgot to mention, we also do a weekly hack night. It starts with every week. Every Wednesday night, other than the first Wednesday month for August Meetup, which is that is fun. It's kind of opposite of this. It's completely unstructured, informal. So you get a chance to work with other smart people. It's all good. Okay. So I'm just going to jump right into it. Today we're going to be talking about SonicPi. Anyone ever heard of SonicPi? All right, Quentin, you're going to be picked on because I know exactly how much you know. Okay, so this is SonicPi. If you want to play with it tonight, which I hope you do, go to their website and download it now. It's about a 60 meg download. It's not that big, but good thing to do and just get installed. And I'm just going to dive right into it. So we're going to be talking about Ruby and SonicPi. The focus of this isn't so much going to be a strong presentation, more like a brief walkthrough and then some group activities and start playing with things together, and more interactive than me just teaching you how to do it. There's a few reasons behind this. I'll explain those in just a minute. So what SonicPi is the ability to write code to make music. Did anybody, who here went out to the Mountain West Ruby Conf this spring? Okay. So out there I gave a little talk on making music with Ruby, walked you through how to create like sine waves and actually create notes and music and scales and things like that, really from the ground up. A lot of the same principles are taught through this project, but in a much simpler way where you're not actually having to build it all. Somebody's already built it for you, and you can just start writing music. So the whole idea is you can write any type of music out there, classical, electronic, whatever. At the end of the day, we're creating noise, and all music is organized noise, right? So the purpose behind SonicPi is pretty interesting. It's an open source project. All of its code's on GitHub. The majority of it is in Ruby. There's a few little C things for audio type playback and whatnot. But why Pi? The idea is that it was built to run on a Raspberry Pi, so it's very light. The Raspberry Pi is a $40 computer, which means if you're learning how to program or learning how to create music, the barrier to entry there is very cheap, right? For $40, most students and other people could get into that. It's developed by the computer laboratory at University of Cambridge in England. It's written in Ruby. The community is very active, but the focus is not so much music, it's education, and kind of two-part. So what you do with all of this is really more important than the language you choose to do it in, and that's kind of the nature of programming anyways. You know, we happen to be Ruby developers, but as a Rails developer, you probably dabble in anywhere from 8 to 20 languages just by the sheer nature of building full stack frameworks and other things. I hope the idea generally behind your programming philosophy is using the right tools for the job to get things done and not being so much of a stickler to, well, we have to do this only in Ruby, only in this, whatever. So the purpose of this project is really to teach people programming and to teach people how to write music at the same time. Who here has been programming for less than a year? Okay. I want to just ask, what are some of the biggest challenges you've seen in programming? Like from the first step, your first time doing it, like what challenges do you see often? Yeah. Right. Great. That's a huge challenge. And it's a challenge that we face every day, even the longer you do it, until you finally understand anything's really possible, but what is anything, you know, and how do I get there? That's awesome feedback. Thank you. Anyone else? Okay. Anyone else remember any challenges from when they first started programming? Yeah. Great. The comment was just right. So the comment was just understanding everything, variables, methods, whatever. If you get that away, you're awesome. I'm not awesome. I didn't get that right away. I started in design and eased my way into it. But there's so much to learn, and with open source being the way it is now, you know, new technologies are developing faster than any one person could ever keep up with. You know, it's just not realistic. One of the challenges that I see often in educating others and also in introducing people to programming is that the feedback loop between the time you start programming and actually getting something to come back that's impressive and entertaining and worth your time, that feedback loop is very long. It's very large most of the time. So this project really aims at shortening, closing that feedback loop. You type something, you get instant, audible feedback based on what you're doing. When I first started learning JavaScript, it was like, oh great, I logged something to a console that I had no idea how to get to. Or in Ruby, it was, oh great, I can't even install Ruby because RVM didn't work very well and whatever, you know. You know, just writing puts hello world isn't that impressive. It's just not, you know. So I think, you know, learning a full framework or learning a full language or whatever, it's such a giant obstacle to tackle that that feedback loop is often too large, and it's not very suitable to teach new people and beginners. It's really not, because you get bored. You couldn't teach a kid Rails day one, let alone Spring or .NET or any of the other frameworks out there, right? So the focus is really kind of education, and education through interaction. So what can you learn by using and learning SonicPi? Computer science concepts, okay? All of these different things. I'm not going to read them out. You can read them. But these are important principles in computer science that only come with experience. You don't learn these things just by reading a book or going through an interactive tutorial. You learn these things here by hands-on, real-time, playing with things, breaking things, having them explode in your face. Okay? These are things that really, once you've mastered or at least got a good grasp of understanding of these things in this list, you can go work in any language, in any framework, and whatever. Those things don't really get in the way anymore. So the whole idea is teaching programming through music and like I said, it's built with the idea that it could run on a Raspberry Pi or Linux or Windows or the other one, OS X. Let's get started. There's a few just basic things I'm going to teach you about music. I'm not trying to teach you music or music theory here. If you want to learn some music theory stuff, you can go watch my Mountain West Ruby talk. I go through the basics of music theory there. That's pretty good. Or talk to a piano teacher or a voice teacher or something like that. So a few basic things to understand. SonicPi is built on creating music with MIDI and throwing MIDI notes into a sequencer. So there's a few basic things to understand. This is kind of how MIDI notes and standard music notation work. You basically have all of your different notes, the 12 different notes there, and then you have different octaves or ranges that they play, okay? So if you're looking at a keyboard, they kind of, the numbers you see here correlate with the numbers of keys on a keyboard. So this is kind of the idea. C4, this fourth octave range is what we'd call like middle C, right? 267 hertz or whatever. Middle A, this would be the standard frequency that all Western music's based off of, 440 hertz, right? And so in using SonicPi, we're going to refer to notes like this, like C on the third octave would just be C3, or C on the fourth octave would just be C. Yes, you could do C4. You can just use these symbols to reference them. Likewise, G would be G5, et cetera, et cetera, et cetera. So that's kind of the way that we're going to refer to this musical notation programmatically. So we're going to walk through a few things. SonicPi gives you the ability to write scales, use different scales, use different chords. Is anyone familiar with ADSR? Okay, we got two music people. So this is basically the idea of the characteristics of the notes you're playing. ADSR, we call it attack, decay, sustain, and release. It's basically the idea of how notes come out. If there were zero attack, it would just be like boom, like a very abrupt, sharp sound coming in with no fade in on that attack, okay? The decay is the amount of time between that initial note registering and the rest of the sustaining note that you hear. So if you heard like a large boom and then it like evened out, you'd hear that decay going down to the sustain. That's normally the level of the note that's the duration of your note, if that makes sense. Then the release is the fade out, okay? This is kind of important to understand in writing music, just because we're gonna see how we can use the SonicPi things around these principles and control these as we go. That's the end of my slides. Let's make some music. Okay, so who here was able to download SonicPi? Awesome. Okay, anyone having trouble doing it, or you're just not there yet, or you just don't care? What's that? Sorry, I can't hear you very well. This fan is really bad. Okay, then it'll just install stuff or anything. Okay, so this is their website. You can check it out. They have different videos on it. I'm not going to spend a lot of time going into teaching you every single thing about it, for the sole purpose that they do such a great job at doing it already. There's built-in tutorials right in it. I'll go through a few of those just right at the beginning. Excuse me. But remember, the focus of this is education. It's very well documented, and they do a better job than you could get from me. So I encourage you to go through the tutorial kind of on your own. I'm going to hit a few key parts in it. But honestly, it'd be a waste of all of our time if I just sat here and went through the tutorial that they give you for free, right? But here's the idea. So the SonicPi, they built just a simple GUI around this tool. So the idea is that we're going to play notes, and then we're going to write code, and we're going to send the code through a sequencer. Can anyone tell me what a sequencer is? Okay, it's the idea that you throw stuff into it and it just plays things in a sequence. That's it. So the idea is that, you know, if we wanted to play some notes, we could tell it when to start, when to stop, when to do things together, right? If anyone's listening to music, you know that there's normally parts and sections and groups of music. We have intros, we have choruses, we have whatever. It all runs in a specific order, not just plays all the sounds at once, right? So this is the interface. Here's your main workstation here where you actually write code. There's a little log that goes out here on the right, and there's a few things that are important to understand. First off, it's just Ruby, and it's just a DSL or a domain-specific language around writing music with Ruby in SonicPi. So everything you know about Ruby applies here. It's Ruby. It runs through a Ruby parser that uses their DSL to write music. So I'm going to show you something. It's really easy to play music. We can play notes just like this, just by writing play 38. This would be the 38th key on a full piano. Most pianos aren't a full piano, but the 38th key. Okay, we could bump that up to 60, bump that up to 65. Oh, that speaker kind of cut out. Interesting. Okay. So we can play notes. We can add things like sleeps to play a note, then wait a little bit, and then play another note. Hear that? I slept for like a quarter of a second. Played 2 notes. Okay, can play a few notes. So we're making music. Okay, so the syntax is pretty simple. I'm going to go through just a brief example first to show you what's possible, and we'll go through a few of the basics. Then I'll show you some things, then we'll explore on our own a little bit. So you can play notes just using kind of standard waves and computer-generated audio, or you can also use synthesizers to give your notes more character. So for example, I could use a piano. Hear how different that sounded than just a pure sine wave. Okay, so when I use that synthesizer, it sounds a lot more like a piano than just pure music, computated waves, right? One of the key things to remember about music is when we generate notes and sounds with computers, oftentimes it's too perfect, it's too clean, it's too crisp, because computers don't make mistakes, right? What makes music really music is the imperfections in the waves that we generate. It's the characteristics of the sounds that we build. It's the idea that the violin sounds beautiful because it has a distinct tone than, say, the recording, right? Not to say the recording is bad, the two sounds are very different. And likewise, with any other instrument out there, they all have distinct tones with slight imperfections. Slight imperfections in tuning, slight imperfections in resonance, and all that's okay, right? So we have synthesizers that are ways of emulating what naturally recorded pianos sound like, and they do a decent job. But once again, they're often a little bit too perfect still. Computer-generated music probably won't be as beautiful as a full orchestra playing the same piece, right? Okay, so I'm going to just jump through this first part of the section here where we can take a look at some of the basics. So you can see here we can create notes, we can add rests between notes. I'm going to show you a principle of SonicPi that's pretty interesting. The main creator of SonicPi, Sam Aaron, he actually uses SonicPi in nightclubs in London as well as a way of live coding music in electronic clubs. So that's just a brief introduction to what's possible with it, okay? This is the idea between a live loop and how you can live code music. So I've got a beat going. Now check this out. I can change the sleep on it. I can hit run again. I'm hitting run right here. And then wait till the next tick comes around and play that. Okay? I can change this. If you look in the interface, they have like different samples and different things you can throw in there. So I could be like, all right, I want to change that sound. It's still playing, the speaker's cutting out. Okay, so I can switch the sound in it just like that. This is the ultimate principle of live coding. Okay, but I can change that on the fly. Okay, I can back up and do different things. So I could even write some new stuff in here. Oh, and I typoed. Okay, I don't like that, so I did it. Okay, so we might decide to add like a sample break snap. I'm not going to add any rate. And we're going to sleep 0.125 there. So what's the idea? There's a few key points here. I'm coding and I'm getting instant feedback. That's pretty cool. So as somebody first learning to program or whatever, it's very approachable. Okay, as you guys saw, I can throw errors. I learned how to debug errors. Runtime error, line sec. This is like our normal Ruby, IRB, console output type stuff, right? Like I said, it's all just Pi. It's all just Ruby, and it'll tell you on line 6 we got an error, undefined method, sample, blah, blah, blah. Okay, so I've got syntax highlighting right there, showing me what's going on. And that zoomed in a lot. I can go back and fix that and start writing some stuff. Okay. And start writing other code. It's like play. And I decide, oh, that's really annoying. Let's comment that out. Okay, so we can start to do things. We're starting to make sounds. I'm not going to call it music just yet, but we're starting to make some sounds. Okay, so like I said, I'm not going to walk a ton through the walkthrough stuff because it's really great. It does a lot of stuff for you already. The whole principle, though, is learning through playing, which is very nice in learning to program. You don't get that in a Java IDE. You don't get that in IRB that much. You just don't get that in a lot of other ways of programming that we're used to, okay? First thing to recognize when you're going about this, there are no mistakes. Every time you screw up, you're learning something. So play with it and have fun. And to start simple. Start with something simple like this and augment it. Start with somebody else's example and change it. Start with something and mess with it and break it and do things. So it's a very exploratory way of learning to code and learning to write music. Cool. So they have some pretty cool sections here that just introduce the basics. I've showed you like a little bit of this already. Show you another one. So, you know, we figured out how to just play a note, right? Now, there's an interesting principle. If you say play like other notes, what do you think will happen here? Will it play these two sequentially? Or it'll play them both at once. So we can write chords just by stringing things together. Okay? We can do things like use the chord names even. If I wanted to do like, let's do C, G, E, okay? We can start to create chords like that. Play, E, 5. We got a full chord there, right? So that's really all it is you got beeps. You can string multiple beeps together to make chords. We can do things like use synthesizers And all of this stuff's right here in the interface. Like if I want to use a synthesizer, let's see here. Let's look at the synthesizers they have. So here's that piano one. I could just do like use synth piano, play that same thing. Sounds a lot nicer than just pure sine waves. I could use a saw, just like a pad, right? Whoops, coming to that. Right? Okay. I can even use their language features to randomize this. I could be like saw piano dot choose. One time it's the saw, the other time it's the piano, right? Let's see. Throw different things in there. Dole bell. So this is kind of an interesting concept because I can work with multiple instruments, but because I can program, I can write anything. But what is this anything I can write, right? Okay. I don't feel like that's using different ones actually. Whatever. Okay, so we can make different beats, we can play chords. We can start to construct melodies by adding sleeps in between them, right, like walking up a scale or something. Make little arpeggios. Oops. I got a typo because I copied and pasted poorly. One of the interesting things is you can even play like in between notes if you don't want perfect pitch. So I could do like 75.35 and 72.75, and that's not going to be a perfectly tuned note. You felt that, right? Sounded like a doorbell. So that's the idea. We can make beeps, we can make sounds, we can make chords. All right, so let's talk about a few other things here. We can add parameters into our code to start to do other things. So the whole attack, decay, sustain, release thing I talked about, you can start throwing different parameters into here to change all that. We can do things like, let's make the amplitude on this one louder. See how much louder that first one was, or quieter. What did I do wrong? What? Ah! You can't make a sleep quieter. Right? So you can start to do things like that. You can even change if you want it to go stereo through both ears, or through the left or through the right, just by doing a pan on it. So you could do like -1 to throw that through the left speaker, +1 to throw that through the right speaker. You can only kind of tell with this, but you guys get the idea, right? Okay, let me dial that one down. It's a little annoying. Oh, I killed my sleep. But hear how one went through one channel, the other went through the other channel. Okay. You can even, so like I said, you can use different synths. You can even switch synths along the way. So if I wanted to like use synth saw here, use synth piano here, right? Use synth, that's another one. We'll grab a FM. So we can switch things as we go. It's beautiful. Okay, this isn't music yet, it's noise. So you can even do things like play notes, have them go specific durations. Let's have this one like release after 2 seconds. Let's have this one release in ½ a second, and that one will be normal. What did I do wrong? What? Thank you. Now notice it didn't wait for that one to finish, right? That first one kept playing and the other ones went through at the right times. This is really ugly right here, by the way. I'm gonna make those some better sounds rather than these off variables, just for our own benefit. Oh yeah, and with 4, you don't really need to use that. You can just do the full number. Okay. So we can tackle the release. We can tackle, with that, we could also like cue the attack stuff like I was talking about. Let's say I want it to fade in a little bit. So I'm gonna have it attack over the course of 1 second. You hear that fade in on that first one, right? And notice how these signs are looking, these waves are looking as I do that. So it fades in, it hits, sustains, and then it releases over that amount of time, okay? So we can control all these different variables, which is kind of interesting. So you can change all those values. We can even change the sustain on it. Let's have it sustain for 2 seconds and release in 1 second. So it'll basically go up, hold, then down. Alright. Let's make that not saw so it doesn't make you all deaf. That was very quiet. Alright. That's kind of the idea. So we can do that on notes. Alright. So we kind of get that. We can start playing some notes. We could start strumming some melodies along. But on top of that, we can even use samples, things that have already been recorded. So we could do something like this. Let's use a sample. An ambient lunar landing. Okay. All right. So you can incorporate that with music. Okay. So awesome. All right, so we can start to bring some stuff together. Play some notes. All right. Now we can start to have some fun and do something like, let's create a live loop where we can start playing with this stuff and it keeps going over itself over and over again. That's so fun. All right. So what I really like is that instant feedback, though. We're figuring it out. We're playing things. When we make typos and stuff, it tells us about it. We're learning to create music and kind of program at the same time, which is cool, right? Okay. So on top of that, I'm not going to go through every single one of these, but you can throw in parameters to samples the same way. Same things, amplitude and panning. If you had a sample, something pre-recorded, you could run it at the normal speed. You could run it faster, slower, change the pitch on it. You can do things to it. You can send it through the left speaker or the right speaker. You could alternate those very quickly to make someone dizzy or whatever. It walks through like stretching samples. They also have a bunch of language features built in, like randomization. Like if I could copy and paste, it's not copy and pasting. Okay, when it does that. Copy. Okay. Like I could play a random note between 50 and 100. Okay, let me throw that in a live loop. Live loop, random note. 2. Let me have it sleep. It's beautiful. Okay, if that doesn't drive you nuts. You can even write messages like, this is my note. Okay, you can assign variables and things like, just like normal Ruby stuff. My note equals that, play my note. This is my note, and we can interpolate it in there, just normal Ruby stuff. Notice my comments coming out here in my logger over here. So I can write music, give myself reminders where I need to come in and do things and whatever. It's kind of interesting, right? Any questions so far? Okay, I'm almost done talking a lot. So there's a bunch of different programming structures. It walks you through blocks, it walks you through iterations, it walks you through loops. Like here's an example, let's say we have something. Okay, if I wanted to play that 3 times, I could just copy and paste that 3 times. But those who know anything about programming know that you could also just do like, 3 times do it again, right? So it walks you through that stuff. You can do embedded loops just like you can in Ruby. It's just Ruby, right? Like loops within loops and other loops within loops. It kind of sounds like music all of a sudden, right? So then you can start doing something like this. Like let's create a live loop and call this the drum beat. If we do that, hit my little, okay. So I'm going, I can start creating a melody. So beautiful. Dial that down for a sec. There we go. Okay. But it's fun. It's cool. You can do things. Okay. All right. But look how easy like this drum beat is. I'm loading a sample, drum heavy kick, another sample, this electric blip, another sample, an electric snare. So I'm gonna play that heavy kick once every 4 beats. Boom, boom, boom. Right. Let me mute all this crap. Okay. A little bleep, 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 bleep. I want to do it the first 2 bars, twice during the first 2 bars. Hear that? Okay. Versus if I did it every bar. Or whatever. Okay. So creating a drum beat's not all that hard. I mean, that's like, 10 lines of code or whatever. Start composing melodies on top of it. So like I said, it walks you through other programming things. You can write conditional statements, like randomization things, as you see here. This one will say, hey, every other time, like flip a coin, and if it's 1, we're going to kick. Otherwise, we're going to close. So it's just random, like choose one or the other. Okay. Oh yeah, and if I run things, I can run them again in tandem. So I could like back up and keep that running. Okay. Okay. It's pretty sweet. It's all kinds of beautiful. You can stop it all too. All right, so that's kind of interesting, right? It's all threaded. It's running these things in separate threads, so you can manage these differently. You can also programmatically tell it to stop playing, stop at a certain interval, or stop when a certain event happens. So it teaches you about threads and how that works. Threads run in different loops. So you can see here how you can run this, like within a thread, do something. So some things can be going at certain intervals, other things can be going at certain intervals. All right, so it walks you through that. Walks you through some of the sound effects they have. They have things like reverb and flanger and different types of just music sound effects that you might apply to things. We'll go back to my drum beat sample, and we'll do like with effects. Let's do a reverb, and we'll throw that across that whole thing. Now it's got some reverb on that drum beat. Hear the difference there? Not really. Yeah, there you go. See, it just came in right there. So when you live play, it comes in at the beginning of the next bar, so that it's not just going to like interrupt what you're doing either, which is kind of nice. Okay. And just talks a little bit more about organizing your data. They have some helper methods on like chords, which are pretty nice. I could do something like, let's play a chord, E3 minor. It just knows that, or major, or whatever. So I can start to do things like that. I could also play chord patterns, which is going to arpeggize the notes within the chord, so it'll walk up them, okay? And this is doing like an E minor 7, okay? So this is kind of interesting. We can also, they have this thing called the play pattern timed, where you can run a chord and you can do it across certain times and sleep across them. So that code right there is the equivalent of writing all of that right there, like we did in the beginning. See that? It's really interesting. So we can dry things up a lot and say, I want to arpeggize that code, and I want every other one to run at 1/4 of a second versus 1/2 of a second. And you can string things in like that. Yeah. Great question. You're just writing it here. You can save it here as a Ruby file. You can record it as a WAV file. So I'm hitting record right now. I hit play. I hit stop recording, and I saves it as a WAV. So both, either. Yes. Yes, yes, yes. What? It actually can. You can hook up like a MIDI controller to it. There's this pretty interesting project I saw. Where was it? I think it was just off their homepage. Nope. SonicPi. Let's see here. MIDI controller. This one. Where they started building these awesome, and when I say awesome, I mean awesome MIDI controllers that look like that, out of like Arduino boards and just different stuff. So that'd be kind of cool to play with. I don't know, it's like Rock Band meets real life or something, you know? But yeah, they got this hooked up, like how to make your own SonicPi controller. So I want one of you to go make that and show it to me. So it's pretty cool. And I don't know how all the connection bindings work and all that stuff. I haven't gotten into the MIDI side of it at all. But yeah, you can do it, figure it out, and let me know if you have that ambition. You can do time scales, you can do different things. So you start looking at that and you go, okay, you can start to build some interesting stuff with a little bit of code. Okay. So there's more there. You guys can walk through the tutorials and play a lot of that stuff. I'm going to show you just some basic implementations and some basic things of some things that I've written, some things that I've gotten off of Gist and other sources and other things people have done, just to show what people are doing with it and what you can do with it. Not only can we make music, but we can make just sounds. Like, you know, when you go to the movies and you hear that like THX note. Wait for it. It's a dirty THX note, right? So you can do things. You can detune things and slide and change the volume over time, you know? Here's a little dubstep one I've got for you. So I'm just using a saw synthesizer picking some random notes on that little wobbly sound. Okay, so you can pass in different things to start to make some music. There's just some funky drums. Alright, so I'm going to show you a couple of examples. Let's go here. So this one, we're going to do some harmonized scales. So we're just going to walk up and down scales, and harmonize with the notes that are playing. It's pretty easy. I've just defined like the different notes and then their accompanying harmonies with it. So this is just going to play every tonic, 1 to 12, every tone and every semitone. Walk all the way up and all the way down on each one. Okay, but that whole thing's only 50 lines of code. Like, it keeps going. But it's kind of interesting, right? All right. I'm going to show you another one that's kind of interesting. This one's kind of the concept of ticks, right? In samples, you know, we don't really like to refer to music in raw seconds. It's hard. We like to use like beats per minute and ticks and bars and beats per count and things like that. So here's an example of kind of working with the different ticks and changing some things based on ticks. I'm just going to play it. It's 45 lines of code, comments included. But check this out. So I'm doing a volume fade over 20 seconds here. I'm grabbing different synths for every one of these melody notes in here. So it's kind of cool. You can do things like this too, like use BPM 150. Speed it up a lot, you know. Go a little faster. So it's kind of cool that you can like live code that and mess with it and do things. The standard BPM it runs out at 60. Well, that's kind of the idea, right? It's like do a lot of crazy things. Let's see. Let me show you another one. Let me show you this one. It's my. So this is some piano harmonies. So it's pretty cool though. Like you can like different styles of music, different noises. I'll show you one other one. I want to show you this one. Yeah. We can make noise like an ocean. So like define all these different drum patterns and play them in a certain way. We have like notes going on that are just taking different patterns and running through them, throwing different chords through them, running in different note ranges. So it's like random but semi-controlled. And two other ones to show you. So a lot of this is just randomly generated music, which is super interesting to me. It's like, I'm not having to score a melody here. But you can use like music theory principles to still create decent sounds, right? And the last one I want to show you is SonicPi Boogie. So let me explain a few things going on here. This main thing you hear is just my melody. There's like the first part, second part, the third part. I just times them and added them all together. I like walk up it, walk down it. It's just like putting things together. So you've got like beats going on, rhythms going on, melodies going on. We fade it out at the end or whatever. I can put little like cues in there, like, hey, push stop, because it's gonna end here in a second. See that? There's my little now press stop thing. So you can do a lot with it. That's it on the demo for me. Let's play with it, see what we can come up with. Whole key is start basic, make mistakes, figure out the structure of it, figure out how to make like repeating loops and repeating beats, make one track going, then start writing some melodies or add some instruments. They have a whole bunch of synths you can use there. That's a great starting place. Effects, you can use samples, and then all of their DSL stuff's defined in this language stuff. So, you know, start working through the tutorial. And yeah, let's just play with it a little bit. Cool. Any questions? Anything else for there? Yeah. Yeah. Yes and yes. Yeah, they have a lot of their own methods that do. You can certainly use Ruby methods in there, but yeah, you notice like this guy here. So you have a random number, which in Ruby you just define a thing. They have this double R method that takes two values to generate it within it. They have like a random integer number to generate a random whole number between 2 points inclusively. So if I wanted a whole number between 1 and 10, not like a float in between it, I could grab that. And so you can use normal Ruby methods. There are a bunch of these DSL methods that he's defined that they've built already that just are kind of more adapted for use with music is probably a good way of saying it. So they have all these things in here, like you can even get back values, like get the current BPM. That way you could write code based around, hey, did the BPM go up? Once it hits a certain point, go back down, or start to do those type of things. You notice like when I was doing randomization stuff, I could create random notes like this, but if I had an array of things, I'd use a choose method rather than just like a take method or a pluck method or something like that. And so try the Ruby ones you know, see if they work well or not. It does just run it all through a Ruby processor. I mean, you're seeing the error outputs come back as like normal stuff you'd see in IRB. And so it is just running it through a Ruby runtime and processing it all. Cool. Okay, so yeah, I think if any of you don't have it installed on your computers, just work next to somebody who does. You'll have just as much fun, and let's just kind of hack on it for a while. If you come up with something cool, feel free to come plug in and show the class. And yeah, that's it for me. That's SonicPi. I did record this whole thing on Google Hangouts. Ooh, we're going into infinity. I just posted on the Slack group, so you can see that all later. If there's anything there you want to see again. Okay, I'm going to stop that broadcast though.